In this video, we're going to talk about how to solve equations using factoring. So this is going to be used a lot in polynomials, in quadratic, cubic functions, even rationals to help determine key points of a graph. So we want to make sure that the equation is in standard form, and so it's equal to 0. So standard form would be ax squared plus bx plus c equals 0. And as always, we want to see if we can factor out a common monomial first to simplify it. Once we do that, or if we can't do that, we recognize which different method we factor the equation. And we just want to simplify as much as possible and get down to as many factors as we can. And once we have that, then we use the zero product property to solve for x. So this first example, we've got x squared plus 5 equals 6x. We're not always going to be set up in standard form right away. So in this case, we see that we've got to move the 6x over. So we have it set equal to 0. So now we have a pretty simple trinomial where a equals 1. That tells me we can just do our simple factoring. I know that 5 times 1 is 5, and 5 plus 1 is 6, but since this is negative, then this factors to x minus 5 times x minus 1, and that's still equal to 0. So now we have our two factors. We can't simplify it anymore, and we know that if some quantity here times another quantity is equal to 0, at least one of those two must be equal to 0. Well, if x is 5 here, 5 minus 5 is 0. If x is 1, 1 minus 1 is 0. So x could be equal to 5 or 1. Okay. One more example here. In this case, it doesn't look like standard form like in the previous example. Again, that doesn't necessarily mean that we can't factor normally, which is why it's really important to see if we can factor out a common monomial first, simplify it in a way that looks like it factors in a way that we're familiar with. So I noticed that both coefficients 2 and 32 are even numbers. We can factor out a 2, and they both have an x. So we're going to factor out a 2x. We get 2x times x squared minus 16. Now this looks familiar. It's not a trinomial, but we've got a perfect square here as our c value. It's negative, and it has no b value. So that reminds me that it's a difference of two squares. 4 times negative 4 is 16. Negative 16. And 4 plus negative 4 is 0. So we now have three factors, 2x, x minus 4, and x plus 4. So there are possible three values for x. Well, if x is 0 here, 2 times 0, that would make this quantity 0. If x is 4, then this quantity here is 0. If x is negative 4, then this is 0. So again, 0, 4, and negative 4 are our values for x.